Alright, chemistry, last normal week of class, if you want to call it a normal week of class. But this week we're going to talk some more about boiling point elevation and freezing point depression. Today, Wednesday, and then Friday you'll have another take-home lab over freezing point depression. You had a take-home lab over molarity and solution rates, like the rates at which they dissolve, the rate at which solutes dissolve into solvents to make solutions. This lab is your second lab of the quarantine, and it is over freezing point depression. So that'll be your second and final lab. You will not have a final exam, obviously. This lab will help to sort of evaluate your skills, that sort of thing. We'll call it that. So you'll have a normal homework today that'll be due on Friday, and then you'll have your Friday lab, which will be due on Tuesday of all days, not Wednesday, Tuesday of all days, I know. If you're a senior, all right, if you're a senior, you do not have to do the lab. You still have to do this homework, but not the lab. All right, senior grades will be done on Friday. So anything due after Friday, if you're a senior, you don't have to do. And I think there's literally 2 seniors, so not a huge deal anyways. But okay, so freezing point depression and boiling point elevation we have talked about, right? But we've only talked about once, and if I'm going to give you a lab over it, I just want to refresh your memory. And by refresh your memory, I mean talk about it entirely again. That's, I think, the nature of online learning. It's a bit more difficult to remember everything, perhaps. So remember, when it comes to freezing point depression and boiling point elevation, we're dealing with molality. Even though we usually deal with molarity, we're dealing with molality here. All right, so we're talking about moles per kilogram. That's specifically moles of solute per kilogram of solvent. All right, molarity is moles per liter of solution. This is moles per kilogram of solvent. It's a little different. Luckily for us, a liter of water is a kilogram, so it doesn't really matter. But it is solvent versus solution. Okay, so boiling point elevation. Conceptually, it's this. When you add stuff to a liquid, its boiling point goes up. Meaning, if you dissolve something in water, you need more heat to boil the water. Right? The water doesn't boil at 100, it boils at 105, or whatever, degrees Celsius. And freezing point depression is much the same. When you add stuff to a solvent, it must be colder than usual to freeze. Right? So if you add salt to water, instead of freezing at 0, it'll freeze at, say, -5 Celsius, something like that, right? So it depends on how much stuff you add, and that's how much it changes the boiling point or freezing point, right? So let's first talk about the math behind boiling point, then we'll talk about the math behind freezing point. On your homework, you'll have a question about boiling or freezing, and then in your lab, you'll have to actually do it. You're going to actually measure the difference in freezing point that happens with when you add stuff to water. And you'll be able to do it without any tools besides like cups, because I'm not assuming you have a thermometer or anything like that. So first up, boiling point elevation. The change in the temperature of boiling, which is delta TB, you see on the bottom left there, down there. Delta TB equals KB times M. So the change in the temperature of boiling is equal to the constant of boiling of your solvent times the molality of your solution. So we're just dealing with water, really, but I've given you some other ones that are common and commonly used in a chemical facility, and where this might matter, but let's just deal with water. So the amount the boiling point changes is 0.512 times the molality of the solution, so at least with water. So if we had, say, a 1 molal solution of anything, salt, sugar, doesn't matter, or whatever, the boiling point would be 100.512. If we had a 2 molal, it would be 101.024, right, and so on, because you just, that KB is how much higher it goes. All right, so if you had a 10 molal solution, the boiling point of water would be 105.12, right? So that's how that works. I'm going to show you an example. All right, so what is the boiling point of a 0.029 molal aqueous solution of sodium chloride? This is a level of saltiness, NaCl, sodium chloride is salt, right? It's a level of saltiness you would commonly find in nature, depending on where you're at. If you can find it in like a freshwater, seawater, delta area, that sort of thing. So this is a real number, a real like solution you could find. And so the question is like, what's the boiling point? Is it any different than pure water? And how different is it? Well, it's pretty easy to calculate. All right, you'll just take the equation, change in the temperature of boiling, delta TB, equals the constant of boiling times molality. Well, water's constant of boiling is 0.512, and the molality of this solution is 0.029. I didn't make calculate molality. What a nice guy, right? So you plug those numbers into the equation, and then you multiply them together, and you get 0.015. Okay, well, what's the boiling point of water? It's 100 Celsius, easy to remember. So 100 plus 0.015 is 100.015. And so that's the new boiling point of water. That is the new boiling point. The boiling point elevation is 0.015 degrees Celsius because that's how much it went up. So the elevation is how much it goes up, and then there's the new boiling point. So you have to keep in mind with questions about this that you can encounter questions that ask for the elevation, or ask for the boiling point, or ask for the freezing point depression, or ask for the new freezing point, right? Which would be different numbers, right? For boiling point, I mean, if this question said what's the boiling point elevation, it'd be 0.015. If it says what's the boiling point, it's 100.015. So that's important to keep straight. And on your homework, it's going to ask for one or the other, and so you have to actually solve for that. For the second one, freezing point depression. Freezing point depression works inversely to boiling point elevation, right? And when you add stuff to a solvent, and I mean in our case we're talking about water, when you add stuff to water, it freezes at a lower temperature, so it stays liquid at 0. For this reason, there's a lot of like real world application for this, right? We've talked about it before, but you can add salt to roads, and even at 0 Celsius outside, the roads will be liquid water instead of ice because the new water freezing point's like -2. Practically, you can add this to a cooler. So you're going to the beach and you have all your pop and waters in a cooler. You can just add ice and water, and the temperature of the water will be about 0 degrees Celsius. Or you can add salt, like a bunch of salt and ice and water, and the temperature of the water will be like -5 Celsius, which means your drinks will be much colder than normal, right? So even in everyday stuff, you just add a bunch of salt because it's cheap. You could add anything that dissolves in water, but salt is the cheapest and isn't sticky like sugar. So you just add a bunch of salt to your water and ice, and your drinks will be colder because the water they're sitting in will be colder, right? Because usually in ice water, the coldest it can be is 0 Celsius, or right above 0 Celsius, right? Maybe 1 Celsius, because if it gets to 0, it's all ice, it freezes. Well, if you add a bunch of salt, it can go lower than 0 because its freezing point is lower. And you can calculate just how much lower using math. So you can literally, I mean, like calculate the amount of salt you need to add to your cooler, although in practical everyday chemistry, even a chemist is just gonna like crack open a big thing of salt and like pour it in, but you know. Here's how you do it. The change in the temperature of freezing is equal to the constant of freezing for that solvent times the molality of the solution. We only care about water with freezing point depression. I mean, I've never had to calculate a freezing point depression for anything but water, and I've been a chemist. So the change in the temperature of freezing is constant freezing times molality. So let's say you want to know the freezing point of a 0.15 molal aqueous solution of salt. So you make a solution that's 0.15 molality of salt. Okay, what's the new freezing point? Notice it asks for what's the freezing point, not what's the depression. Let's solve that. We got to plug in our Kf and our M. Now, our Kf for water is 1.86. That's given up here, right? So you plug that in. That's 1.86. Your M is given at 0.15 molality. So you multiply those numbers together, you get 0.279 degrees Celsius. Our freezing point depression is 0.279 degrees Celsius. The freezing point is changing by 0.279 degrees Celsius. But what's the new freezing point? Well, what's the original freezing point? Well, water freezes at 0. So 0 minus our freezing point depression gives us negative 0.279 degrees Celsius. Something like 31 Fahrenheit, basically. So there you are. You just literally plug in two numbers, multiply them together, that gives you your depression. If you're solving for the new freezing point, you have to take 0 minus your depression. If you're solving for a new boiling point, you take 0, or you take 100 plus your elevation, right? Same way. So that's what you're doing for your homework. Same idea. You go to OnCampus assignments. It'll be right there. It's assigned on 5/13. It's due on 5/15. That's Friday. Get it done, turn it in. Don't do it late, all right? Because if you're a senior, all of your stuff is due on 5/15, or it's gone forever. You get a 0. If you're a sophomore through junior, like the rest of y'all in this chemistry class, all of your stuff will be due on 5/22. That is May 22nd, a Friday, and then that's it. It's like a drop dead date. If you haven't done your homework by 5/22, too bad. There's the occasional special circumstance or special thing, which is normal, right? You have a tragedy in the family or something on a Thursday, you know, email me, email your counselor, all that. But barring like family emergencies and all the typical exceptions to rules, your homework is due on May 22nd. I'm putting in the grades on May 22nd during the day. I'm not talking May 22nd at midnight. I'm putting them in at like 5 p.m. All right, so get everything done by Thursday the 21st at the absolute latest. All right, especially this thing, just do it on time. All right, that's it for the mathy stuff. You'll have a lab on Friday, so look for the video on Friday, and then you'll have a lab sheet, and then some lab questions, all that. So that should be fun, actually. I think it's a fun lab. So I will see you on Friday. Good luck.